instruments. So I talked to their India head, and the the India head basically agreed that what he can do for us is that he can give us trial licenses for software which you guys can use, and we can co-host like a workshop with them. And so he has asked me to submit a proposal, and the he's a good friend of mine. So what I want, I will talk to Professor Ruchir Gupta about it, like what type of timing we want to do in. But we will be able to get some licenses. These are usually very expensive license because these licenses are basically used in industry and in leading companies. So around, if we really need 30 licenses, we are talking somewhere about 7 to 8 lakh rupees. But what I have proposed them, that we can do a joint workshop so that they can get necessary publicity, because they keep approaching me to do a workshop. So we can do a joint workshop in Delhi. What I need from you, I need couple of volunteers who can help me prepare like a document which we can send to them. So it might need some of your class strength, it might need some of the paperwork. So you guys can tell me who want to volunteer for this, for writing like a quick 1 page, 1.5 page proposal with me, and help me arrange this workshop. Any volunteers? Or shall I pick myself?
You want us to tell right now?
No, not right now, later on. So maybe Mansa, you are the CR, right?
Yes.
So I will coordinate with you, and we will need to like do some paperwork, and then we can take approval and go ahead and try to plan it.
Of course.
So that's a good news, I guess. So I hope that we will have some licenses, and we can do like a whole week, either do it on Wednesday, Friday, and maybe if we can do it, if we can do it in continuous time, that's the best. But the problem is, I don't know whether during your semester schedule you will have 1 week where you don't have any work, because you will also have classes and exams. So I am thinking either we do it towards end of the course, or what we can do is that we can do it on Wednesday, Tuesday, your Wednesday, Friday, and maybe over weekend if you guys are free, like over Saturday and Sunday. So we will have to think about it. So let me know what timing will suit, because I'm not sure about academic calendar. I know there will be exams. So what do you guys think? It's better when we do like a 5-day workshop in the end, and if we do that, is it possible for you guys to attend this over weekend? Because this is kind of, it might be little more than your course and your what you will learn in the slides. It's more like a workshop. So what do you guys think, when we should plan it? Any recommendations for that? What do you think, Daksh?
Sir, I think we can check our schedule and come back to you in the next class, maybe, because I think there's a 2-3 days break after the first midsem or something like that. So we can do it in that time.
Okay, what I need from you guys can talk to yourself, your friends and stuff, in WhatsApp or whatever you guys are communicating with, and let me know what will be a good break around 4 to 5 days where we can host this workshop, because it will need a lot of work, installation of softwares, and make sure softwares are running, and then start training. And I am also pushing so that they can provide you certification, which means that you can, if you complete course properly, and if you obtain some kind of you're able to do what tasks are there in that CAD tool, then you can get a Keysight certification, which you can find somewhere, and those have more professional value. So I will talk to him. I'm not sure but what their system is, but I guess we will be able to figure it out. So please think about it and let me know. Okay, so let me just make full screen, and We will start with our lecture today. Today's lecture will be very interesting, as well as little bit you have, if you don't follow anything, please unmute yourself and ask it right away. Because if you don't understand from starting, you will tend to lose the rhythm and you might not understand what's happening. Second thing, what time today's lecture ends?
It's a 2 hour lecture, sir. So 11, I guess.
It's 2 hour lecture. Okay. Good. Okay, so let me start with basic introduction. So I guess you guys all of have seen mobile phones. Everyone is using mobile phones. We see base stations around our house. We talked about base stations last time. So can someone tell me who is the base station, cellular base station provider in India? Any uh, any guesses? Any answers? Who installs these base stations in India?
So TRAI,
Sorry.
the TRAI, the company that sells the bandwidth. Sorry, the organization that sells the bandwidth.
No, but TRAI is Telecom Regulatory Authority of India that just regulates. But who? Okay, let's forget that. Who do you go and buy data and cellular data and connectivity from? What are the key players from which you buy that? Telecom providers.
Sir, BSNL.
Yes, BSNL and Airtel, Jio, Vodafone. So what they are doing, Vodafone, Jio, Airtel, all of these provide you telecom service, correct? You pay whatever, 300 rupees for 5 months, 6 months, you get unlimited data, you get this and that. But who owns the tower where, so Jio will have a tower, Airtel will have a tower, all of them will have their equipment. But who manufactures those equipment? My question was that, like, who makes base station hardware? So you have been using mobile all your life and you use service from, say, Jio. Now, who actually provides the hardware and installs that hardware on a tower? Because that is the radio unit, right? That is the basic radio which has a transmitter, because it is transmitting signal to your phone, as well as, it is also receiving when your phone transmitted back to the base station. So any guesses? Just make a rough guess. If no guesses, then so the thing is, all the hardware in Arvind, please be on time from last time. As I mentioned, I will appreciate if everyone can be on time, because it disturbs the flow. It's already 7:45, so I will appreciate if you can join on time from next time. So what happens is, thank you, thanks a lot. So what happens is, there are main players in India are Samsung, Ericsson, Nokia, and Huawei. I don't know how many of you recently heard a news a lot about Huawei ban, that US banned Huawei from working in US, in Europe. But these are main four players. Ericsson and Nokia are from Europe. Ericsson is headquartered in Sweden. Nokia is headquartered in Oslo, in Norway, I guess. And Huawei is from China, and Samsung, you guys know, Samsung is from Korea. So these are the four players which make systems, like the boxes, the radios, which gets deployed by Airtel, Jio, your BSNL, and so on. So you have to understand, there is one telecom provider, then there is one person who actually makes radios. They do signal processing, they do everything in those radios. And the third set of companies are which make devices. What do you mean by devices? That, say for example, transistor, right? Say example, oscillator. Say for example, your whatever your core chip is. Those are done by a separate set of companies, which are Qualcomm, NXP Semiconductors, Wolfspeed, Triquint, and majority of these companies are actually based out of US and Europe. So technically in India, what is happening, and you should get this very clearly in your heads, because unlike software sector, in this particular field, we are still the deployers of the technology. We are not the builders of the technology. That's why there has been a very good push from the current government to start manufacturing. And if you get chance, every year in India, there is something called as India Mobile Congress. It is one of the world's best events, and students can register there for free. And you guys should definitely go and attend it. It's not very far from JNU. It's actually near Aero City, and it's worth attending. You get to experience and see what exactly is happening in this sector. So this is kind of, I wanted to give this background because when someone says, oh, Jio is bringing 5G to India, that's they're deploying 5G to India. Jio buys majority of its stuff from Samsung. So Samsung built their hardware and their signal processing systems, and then they give it to them to deploy. So now base station, as we discussed last time, and a bunch of you mentioned about it, that there are different frequencies which include which include which include 0.9 mega 900 megahertz, 1.8 gigahertz, 2.6 gigahertz, 3.5 gigahertz, and so on. And then there is another band which is there, which is called millimeter wave band, which is at 28 gigahertz and 40 gigahertz. So this is about base station. Then we all of us have internet at our home. You have those LAN routers, and where you get Wi-Fi from. So that all stuff basically operates at 2.4 and 5.8 gigahertz. And then there is satellite communication, communication which happens directly with satellite. There is C band, KU band. I will discuss more about it. But these are all high frequency communication. So the basic idea is that, wherever we see around us, we find different application of RF and microwave in our daily lives. Now, one question which is very fundamental, like what is a radio frequency and what are microwaves? So I think you guys must have studied electromagnetic spectrum in your school, and I guess in your physics in high school, where depending on the frequency of operation, there are different type of wave depending on their wavelength. So radio, microwave spectrum, they are basically relatively the longer wavelength. Longer wavelength means lower frequency, because if you remember the formula of relationship between frequency and lambda, they are inversely proportional. So majority of the frequencies from radio waves are like from 3 kilohertz up to 300 gigahertz. That's the band for radio frequency and microwave. So microwave frequencies are relatively higher than radio frequencies. So they basically start from 300 megahertz, which is 0.3 gigahertz, to 300 gigahertz. And as you go higher in frequency, your wavelength decreases, your attenuation increases with increase in frequency. But at the same time, when frequency is high, it means you get higher bandwidth. So when people are saying about millimeter wave in 5G, they also means that you can have much higher data rate and much higher bandwidth. So on the right hand side, if you see, it shows what are the different bands. We used to have AM, if you remember, AM, FM. So all of them operates at different bands. Some are at high frequency, very high frequency, ultra high frequency, and so on and so forth. So the basic takeaway is that microwaves are mostly from 300 megahertz up to 300 gigahertz. Below 300 meg, we usually consider it as radio frequency. Now, this is an interesting concept here. I'm not sure how many of you know it, but we have an ionosphere in our atmosphere. Okay. Now, what happens is that ionosphere is actually charged layer. Okay, it get ionizes when sun shines. Then sun is radioactive, right? Like sun emit radio waves. So what happens, that ionizes our ionosphere, and due to which what happens, that low and medium frequency wave, they actually bounce back. So for example, if I'm transmitting a signal, what will happen due to ionization in ionosphere, that signal actually will bounce back. So that what that can do, that can help me to have a communication between to antennas on the surface of Earth. So, for example, I don't know how many of you have heard of ham radios, right? Ham radios work at low frequency. These frequencies are less than 20 megahertz. But the idea is same. They try to send a signal and they bounce back it from ionosphere, and a person on a different part of the world can hear you, basically. So when there are ham radios, they are all over the world. A person from India can talk to a person in US, and it doesn't have any wired connection. It's not a mobile phone, right? It's not something that the base station is transferring to another base station and so on and so forth, right? So basically, the idea here is that ionosphere is used by low and medium frequency radio waves for propagation and for communication. However, microwaves penetrates ionosphere. They can cut through it, they can penetrate through it, and that's why they are very good for communication with the satellite. So most of our satellite communication actually works through microwave. So now maybe let me ask you guys a question. Say I am in US and I give a call, okay, to someone sitting in India, or say I call you over WhatsApp. Can someone explain me how is RF or so-called microwave communication working in that particular case? See, my case is I'm calling from WhatsApp to WhatsApp. So how is that working? What is exactly happening from my phone, or what exactly is happening when, say, I'm trying to make a call from US to India? If you guys don't tell me, I will take names.
Sir, I mean, I want to make a guess. Whatever we say goes to the base station and then it travels through the data lines, I guess, that have been laid out in the sea to the nearest base station to the person.
What Daksh is saying, what happens is that, say, I make a call, my call will, whatever my service provider is, like for example, I make a call from Geo, right? So from Geo, it will go to a Geo tower and there will be radio units of Samsung or whatever companies I told you, right? Then remember one thing, right? All what we are talking about, RF and microwave, is all basically that's all wireless. But majority of the backhauls in today's world, even undersea, they are connected through fiber. So what happens is our backhauls are, there is fiber laid everywhere in the world, starting from India, across the Pacific Ocean. There is the sea. You guys should watch a documentary about how they lay optical fibers inside sea. It's very fascinating. So that's how my signal travels. So technically fiber is the best. You cannot get any service better than fiber, right? But at the same time, the problem is fiber is very costly. And for example, for our internet, we have fiber going from home to home. But for our mobile communication, we need wireless because we keep traveling, we keep switching from one base station to another when we are traveling. So that's why at that time, as Daksh mentioned, the communication happens through the fiber from the sea. So now there is one thing. So I have put some links here. I will upload these slides. So if there is an arrow says checkout, you are supposed to click on that, and it will take you to basically to a website. So this is an interesting project, and why I'm showing it to you guys, anyone can participate in this. And there is a form where they send you these monitors actually, and you can have one in JNU where this is kind of a receiver, and they have an antenna, and it gets powered. And what you can do, you can monitor what are the ionospheric disturbances using this setup. They make basic loop antenna here, and using that loop antenna, you basically can monitor what is happening in the solar ionosphere, how the ionosphere is changing over time. Because when sun is very radioactive, which means sun is emitting at certain frequencies, then our ionosphere gets varied, and you are able to catch those variation in radio domains by building small antenna at house, which is like a loop antenna. It is same as how at metro station they have those circular kind of loops, and they try to move when they're checking, they try to move on your body, and then if there is some resonance, it says beep 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 beep. So it's the same idea. So this loop antenna basically is used to capture the waves which are coming from the sun, because sun is a radioactive element, it's a radio element. And with that we can actually monitor all that at home. So if people are interested, later on, you can send me an email, and I can try to figure out if they are still sending out these monitors in India. They usually give it in a grant form, and a group of students can apply for it. So this is kind of an interesting project if somebody wants to do it. So anyways, I think this is very clear to you now that there are radio frequencies are low frequencies, microwaves are relatively high, and then millimeter wave are the higher frequencies. But ionosphere, the low and medium frequencies bounce back from ionosphere, and that's why some of that we are able to use that for the communication. Okay, now what happens at satellite? This is also important to understand, because you are using all this all your time. How many of you use GPS? We order Uber, we order DoorDash, or whatever you call Zomato. We order the Ola. So within these frequency ranges, if you see here, it says 3 kilohertz to 30 kilohertz. Okay, then 300 kilohertz, 3 megahertz, 30 megahertz. So up to 30 megahertz, it's AM. You remember old, our grandparents used to have those radios where unka AM hota tha, and then they used to have FM. So those all AM radios are basically frequencies which are less than 30 megahertz. No, I don't think it is active anymore. I'm not sure whether it is now or not. But uske baad, then there are higher frequencies, say from 30 megahertz to 300 megahertz. So 30 meg से 300 meg में के बीच में we have VHF, UHF TV, and up to 3 gigahertz band. That's where our GPS operates. So all our GPS, FM radio, our UHF TV, everything is here. And then from 3 to 30, it's more about satellite and microwave telecommunication. So all our satcom, like all the satellite communication, everything happens between 3 to 30, and then above 30 to 300 gigahertz, or say even now people are even going to up to terahertz. These are used for radars, radio astronomy, and even on some airports. I haven't seen those in India, but there are millimeter wave scanners now which can scan your body. So basically, higher frequencies, they don't penetrate much deep into your bodies, but they have very high resolution. So you can use those for imaging of humans if they're carrying something, and so on. So depending on the frequency of operation, there are different bands: L band, S band, X band, and KU band and KA band. So these are, sometimes you will hear, hey, someone is doing a design at S band. So that is nothing but 2 to 4 gigahertz. So L band is mostly used for GPS in your phones, in your cars, and so on. S band is used for mostly for communication, weather, and also at the same time, all the ISS, International Space Station, uses S band. Then X band is higher frequency, 8 to 12, which is mainly used by military and synthetic aperture radars, phased arrays. These are mostly even at the जो अपना airplane रहता है ना, उनके front में you have X band phased arrays or chips, which communicates between ground-based station as well as airplanes. Then you have KU band and Ka band. So up to 40 gigahertz things are being used. And now when Elon Musk is talking about internet from space, I think Tesla is using somewhere X band, and other companies like Virgin Galactic and this one, Virgin Galactic अपना इसकी है ना, the Virgin Airlines की, they are, I guess, richer, yeah. So they are using different band. They are using KU band. And there is also internet from space concept going on in India. If you Google a company called Astrom, The CTO is Neha. She's a good friend of mine, and they are trying to build some Ka band communication system. So their idea is that they want to give internet from space, but they're trying to do it at higher frequencies. Higher the frequencies, higher will be the data rates. So everyone is trying to do that, but the problem is, as you go higher in frequency, your losses are very high, and it becomes very expensive to fabricate these chips. Like for example, in India, ISRO is the only institute which has facility to develop these kind of chips, and they also have very limited quantity, because these fabs takes big money and big investment. And so far, unfortunately, we don't have any commercial level fabs in India. All fabs are in Taiwan, majority of them. Some are in US, China, and Europe, but we don't have anything. So we are still waiting that for that big thing to happen, because that will open a lot of opportunities. But I am positive that in coming five years or so, there will be huge investments in India in sectors of chip manufacturing. So now coming out to cellular wireless infrastructure, we talked about it last time that 5G bands are divided into two categories: sub 6 gigahertz and millimeter wave. Okay, so sub 6 gigahertz is basically 700 meg and from 3.4 to 3.8, and millimeter wave is up to 26 gigahertz. So जो millimeter wave है, as I explained, high frequency means higher, there can be higher loss. So it is mostly for point to point communication. जैसे यहाँ पर आप देखो, you see here, low frequency cell is a bigger cell or a macro cell. Then high frequency 3.5 to 3.8 is actually beaming, say, a community or an apartment complex. But millimeter wave are point to point, which means from, say, this traffic signal light, it will point to a car, or it will, in a stadium, it will point to specific people who are attending a game in a stadium. So millimeter wave has also application to AR VR, which is becoming a very interesting area. Fixed wireless, which again means point to point, and then also smart factories, because smart factories, if you have robotics and you are communicating that robot, you need high communication. Say somebody wants to operate a person, there's a doctor in Delhi and he wants to do an operation in Bombay. Is it possible really? Can we do an operation? So that is one kind of a concept where people say that through AR VR we can actually have a model of a human body, and a doctor will be sitting in Delhi and he will be, say, operating on that particular VR platform, and whatever action he will do, say he make a scar on your body, in your hand, that same thing through wireless communication, it will be a very fast communication with latency of few milliseconds. You will go and you will be able to see that scar on the actual human body, because remotely you will be able to operate. So even automotive cars, right? All automotive cars they work at very high frequencies, like 67, 68 gigahertz is where their all radars are. So automotive may be same concept hai, ki you basically have very high data rate and speed, and you use them for communication. So I put a 5G white paper by Ericsson. You guys should just scroll over it. It's a very nice paper they have written, explaining about what is the potential future of millimeter wave. They also talk about what specifically are the use cases, and how 2G, 3G, 4G, and what is 5G, and how they are mixed up, and at the same time they also discuss different use cases, what are the different applications, and it's kind of interesting to read it. I mean, more or less I have explained you, but they talk about all these things in detail, and in the end they also tell you about different bands in different countries, including India. So just check it out. This is a very good paper if somebody wants to if you read these things, you become more you understand things better, and then you can explain to people when people are talking about 5G and stuff. Now at least if you see someone talking about that, yeah, Jio brought 5G to India, then you will know exactly what Jio did and who was their hardware supplier, and what was done where. So keep checking these out, because I told you guys, maybe in couple of weeks or maybe 2 to 3 weeks down the line, I will ask a group of 2 to 3 people together to send me a topic on which they will like to present at the end of the course. That topic has to be related to wireless technologies. It can be on SATCOM, it can be on 5G, it can be on virtual reality, it can be on machine learning in wireless sector, it can be on millimeter wave communication, it can be on anything you find near wireless communication. You guys will need to send me a topic, and eventually towards end of the course I will like to take a presentation on that. So another very very interesting thing, आप सब लोगों ने माइक्रोवेव देखा होगा. Lot of people have microwave at their home. Can someone explain how microwave works?
Because they emit microwave frequencies that resonate with the water molecules, and those water molecules, when they resonate, they generate heat up our food.
Yeah, that's correct. So what is happening, what he said is that it's very simple, that but where are those microwave frequency coming from?
So there must be a radiator in the...
Yeah, so that radiator is called magnetron. Okay, magnetron is nothing but these are very old tubes. Tubes means traveling wave tube. Like, you know how we read about in chemistry in high school about cathode and anode polarizations and all that stuff. So magnetron is nothing but it's like a traveling wave tube where you try to excite the electrons, and then by that you try to create you try to polarize it, and by doing that using as you explained that you want to heat or you want to create a resonance between the whatever the water molecules are, and with that you create an energy, you increase the energy which basically heats up the food. So this is what has been happening so far. What I'm showing you now, many people haven't seen this because this hasn't been released. It will be released by 2020, and I guess, I'm not sure if you guys, if somebody has seen it, let me know. But these microwaves are turning into these small boxes now, like kind of an idea where you can carry microwave to your school, like you're like it can be carried like a lunchbox eventually. That's what the target is. So your lunchbox will be your microwave oven. And the idea there is you are getting rid of these magnetrons, which are bulky, consumes more power, are very less efficient, with solid state devices, which means you are putting transistors and you are using power amplifiers, and using power amplifiers you are trying to heat up the food. But the beauty is now with a PA you connect, it doesn't show it, but with PA you connect 4 or 5 different antennas. So now what that does is, for example, you are putting like say let's take an example of paneer. Okay, you have a paneer and you have a good friend, both of you are sitting, your good friend says, hey, you know what, I want paneer to be really really roasted and I want it dark and hard, like I really want it to be ekdam kaisa hota, ekdam crispy, very crispy. But the other friend says, no, I don't want it crispy, I just want to defrost it, and I will like to eat it soft, right? So now with the same paneer, you want to heat it in such a way that one portion of the paneer gets heated higher or can be roasted at a higher temperature, but the other part will be at lower temperature. So what happens is these multiple antennas inside microwave oven will create different beam forming, which means that they will concentrate energy on the specific segment of the food. Now because of that you can actually customize if you want to heat that particular part of a food at a higher temperature or a lower temperature, and you can create your own patterns. So this is which will be coming out into the market, I hope by 2020. I think they are figuring out cost models, but I worked on this project in 2016 during my PhD. And it has been under R&D for past 3 to 4 years, but now it is finally happening. So you can read about RF microwave heating and its applications. There is some material available in public domain. So I found it very interesting because this will basically change the world how we look at food heating and cooking applications. even MACD and all, right? Like MACD and all these chains, they have huge microwave ovens, like big ovens, because वो जो MacPuff को और your burgers, they heat it. वो सब those all will also be changed. No more magnetrons, so it becomes more efficient. So now this is interesting. I guess you guys, I don't know how many of you have an iPhone, but of course all of you will have a cell phone. So I found something very interesting when I was trying to prepare these slides, and I wanted you guys to actually understand that. So this is our iPhone, and if you look at the back of the iPhone, this is how it looks like. It has a battery, and if you click here, which will get, I found this very interesting Bloomberg presentation where you can select any iPhone you want. So let's say we want iPhone latest chalo, iPhone X. Okay, so in this, what it shows exact, it will show everything. It will show what each part is. So it has two batteries, which is this and this. Then it shows that it has camera, rear camera, front camera, and then apart from that, then there is this Retina display, which is the major chunk. Then if you know, the iPhone X has wireless charging, right? So wireless charging ke liye what they do, it's very simple concept. They put this case, and this here is the wireless charging coil. This is another topic people can study about wireless power transfer. So this part here is a wireless charging coil, and apart from that, this is the main brain. This part which you see here, it is the main brain of your which is below. Usually, it's below your battery. It has all the ICs or integrated circuits, and I will explain you what kind of circuits those are. So, for example, in a phone, you have Wi-Fi, you have GPS, right? Then you also have memory where you save your data. Then you have a processor, how fast, like laptops, right? Similarly, you have processors. Usually, those processors are from Qualcomm, or they can be from like Apple. Apple and Qualcomm had a big fight recently where they were trying to sue each other because of this processor business. Snapdragon is what Qualcomm is using, and these all are manufactured. Most of them are manufactured in Taiwan, in TSMC, Taiwan Semiconductor Manufacturing Corporation. From there, everything gets to China, where there's a factory where assembling of this takes place and packaging takes place. And then from China, it gets distributed. It goes back to US, and then US sells it. So basically, when people say it gets manufactured in China, they are telling about the assembling happens in China. So it's the manufacturing of different parts and combining of those parts, but the core brain gets manufactured in Taiwan. So you can play around with it. You can see it's pretty good. I found it very interesting and fascinating because the way they have made it, it's kind of interesting. So now let me go to some little technical, because this is something which a high school student can also understand. So what happens is this is exactly the architecture in my cell phone. Okay, so what it contains antenna. Okay, of course antenna to hoga. You are receiving signal and transmitting signal. Then there is.
So this architecture of iPhone, yeah.
See, this is particularly for iPhone, but it is pretty much common for all phones, because क्या है ना कि iPhone में there are more features and it's more high quality. So because of that, what happens is that they chose different vendors. मतलब जैसे Oppo, Vivo है, वो भी same चीज provide कर रहा है at a very low cost, but they might not be taking the most superior, I will say, company's chip. ठीक है? So, but common elements are same. It will have an antenna. Then there will be a front-end module. And this front-end module is kind of a transceiver, which means it will have a receiver as well as a transmitter, because your mobile phone is transmitting as well as receiving. So you see these names: Murata, Skyworks, Infineon, Triquint, then Infineon, Marvel. These all are different semiconductor companies. Majority of these companies are based out of US and Germany. Okay. Why I'm focusing on these things is because, these courses, what we are teaching, you might be very interested, but at the same time, you have to also understand that opportunities, technology opportunities are still outside India in these sectors. Except Bangalore has some companies now which are doing, like Skyworks, Marvel has an office in Bangalore, NXP has an office in India, Infineon has an office now. So now these companies have started coming into India. So anyways, so there is this antenna. So this antenna transmit your signal to base station and receive your signal from base station. Then there is a transceiver. Now within transceiver, if you remember, our phone works on 4G, our phone works on 3G, our phone works for WCD, MA, GSM, everything. So there are multiple modules. Within a module, there are multiple chips. So what will happen is there will be band 1 CDMA, band 2 CDMA, then band 5 and 6 WCDMA. So which means that for different bands, there will be different chips. So which means if there is different chips, it means there are different transmitters, there are different power amplifiers. Basically, power amplifier is a component which amplifies your signal, because say you have certain signal power and your base station, sometimes you're farther from base station and तुम्हारा suddenly वो drop हो जाता है डंडे, like the charging you see in your phone. So now what happens is power amplifier bumps more gain, so which means it is trying to now give more and more power so that it can connect to base station. एक छोटा सा example देता हूँ. Go to a place where there are no signals. ठीक है? Don't put your phone on airplane mode. What you will see, your battery will drain out very fast. The reason for that is because there is no signal. The amplifiers inside your phone will try to push and try to operate at peak power, because they need lot of power, so that they're trying to find the nearest base station. Once they are connected to a base station, they go and start operating at back off. So always when you don't have a signal now, always you should put your phone on at airplane mode. That will save you battery. So anyways, these are different chips. Then there is also a digital baseband processor, which means you are collecting this data at RF, then you down converted that data and bring to baseband frequencies. Baseband frequencies means you bring them to lower frequencies, because ultimately what you are getting, you either receive audio, right, or video. The audio technical idea always is to down convert your signal so that you can process it out as an audio so that you can listen or you can see it. And then there are different things. There are switches, there are LNAs, and then also you will have a Wi-Fi. So there will be a chip for Wi-Fi. Then there will be Bluetooth. There will be a chip for Bluetooth. Then power management, your battery and all that management. Then GPS. There will be a separate chip for GPS. So imagine how complicated the structure is. And no company can afford, like say Apple sells phone, right? What is the beauty of Apple? Why it is expensive? Because they come up with the best cameras, they come up with the best high quality, and their high quality is determined by a bunch of these companies. So it doesn't mean, when we say it's a phone of Apple, doesn't mean everything is owned by Apple inside that phone. Different companies are giving different parts to Apple, but Apple can have very innovative architecture which are patented, which other companies cannot use. Anna? So,
yes, and more secure.
Yeah, I mean, it's vertically integrated. They can have more security features, or they can come up with the front camera, back camera, and so on. So that's why. But what I'm trying to explain here is that it looks very simple, but see how complicated the back end is. Now your brain will blow away now what I will show you now. This main board here, which is the brain. This is actually this, which is shown on right hand side. Okay. The main board consists of many different things. It consists of battery charger, DC-DC converter, LNA, power amplifier, buffer, memory, voltage regulator. So this on a PCB you have multiple different chips which do different things. Okay, sensors you have MEM sensors. You have so many things are there. Now let me take example of this. For example, this big block, this big black block. This is one IC. This package IC. If I open this up, it looks like this. So what basically is happening here is that you are designing something at micron level. Your circuit, that chip will have transmitter, that chip will have down converter, mixers, LNAs, filters. Everything has been fabricated on some process. So this active chip you see is basically your silicon chip on which there will be everything. And these gold wires you are seeing, you know these are called wire bonds. So what you do basically, you wire these using these wires, you bond it out and then package it in one kind of this package. I don't know, you guys might have people who do robotics and stuff, they might have seen these microcontrollers, and वो सब भी जो होता है ना, those are also packages, something is packaged inside that. But microcontrollers are relatively more simpler. These active chips are more expensive. They need very specialized knowledge. So far in India, the designer of chip, people who design chip are very limited. Maybe one or two companies are doing it in Bangalore. Otherwise, what we are doing is we get this package ICs from here and there, and then we try to assemble it. So then, where do you fabricate this chip? I explained we fabricate it in TSMC, Taiwan Semiconductor Corporation, or you can use CMOS. In VLSI, you will study about CMOS. You can manufacture it in CMOS technology, or you can manufacture it in silicon germanium, or now new thing is gallium nitride. तो इतना कॉम्प्लेक्स होता है, मतलब this small chip will take expertise of hundreds of engineers, so much research how to make these chips efficient. Then they will be packaged and then they will be put it in some board in iPhone, which will be combined with other chips from other companies. All together will be going in iPhone. But now the interesting thing is, which you should know and you should do your own research. What is the cost of an iPhone? Can someone tell me? Like
Sir, in
cost
India,
to
it costs more than 1 lakh.
नहीं, वो तो that's the cost for you, but what might be the cost to the company?
Sir,
I think it's less than
30,000.
20,000.
Something like $500.
So cost of, I don't know about iPhone X, but cost for an iPhone say 7 or iPhone 8 is somewhere around $180 to $190, which means 200 को 70 से मल्टीप्लाई कर लो, around 14,000-15,000 rupees. So it's mind-boggling that how much margin an iPhone has. One is because of its brand, and second because this is such a specialized knowledge. Once you start manufacturing this in volumes, your costs are nothing. CMOS is a very cheap, dirt cheap technology, but problem is we don't have expertise. So these are high skilled areas, and unfortunately we haven't been able to promote much in our country, and that was the reason why I was excited to take this course, so that I can motivate some of you to pursue this as a career path. It won't be that easy, but once you reach there, you will be among the top people in the world who can make a difference. So anyways, moving ahead, so this is more about active chip, packaged IC, and you understood so far that there are different elements. When we talk about wireless microwave, it's just not about waves. It's about catching those waves, processing those waves, and getting something usable out of them. So before we go ahead, because now things will get more mathematical from here, I want you, do you have any questions? Any questions so far, or shall I ask question? Okay, so now I will move to new things. From here, we will shift our gears and we will start doing more fundamental stuff. Before we can, of course, we cannot read about how all these things work in this course, but we can at least start understanding some basic things which are used for process of manufacturing and circuits and chips. So first thing is resistors. Can someone tell me what a resistor is?
Sir, a component that resists the flow of current.
So a component that resists the flow of current. This is a good definition for person who doesn't understand microwave. Okay, which means that कोई भी चीज की flow को अगर हम रोकते हैं, if we try to stop a flow of something, that is the resistance. We feel resistance in our relationships, we feel resistance in our life at many places. So the resistor is a similar kind of a thing. Magar, what happens is at RF frequencies, always remember at microwave and as frequencies scale up, no one is real. Nothing, a resistor is no more a resistor. A capacitor is no more a capacitor. An inductor is no more an inductor. So what I'm trying to say here is that, you might have seen these kind of resistors, the one which I have shown above, like which is called film resistor. And these resistors are basically used everywhere in companies and, in projects. But when we are dealing with microwave frequency, we don't use wire resistors. Can someone explain me why we won't use a film resistor at microwave frequency? Any guesses?
So because the metallic part of the resistor would do EMF, I mean, there would be induction happening because of the metal part, and it, defeats the purpose of a resistor.
So who was speaking? Please take your name.
I was Daksh.
तो भाई तुम लोगों का लीडर दक्ष है क्या? हर क्वेश्चन का आंसर सिर्फ दक्ष ही देता है. What's the deal with him? Why nobody else participates? Why? Abhi, I will ask people. So why do you think that a resistor is problematic at higher frequencies? Kunal.
Yes, sir. So due to the coiled wire inserted in that, and this I think some radiates some frequency when some EM wave or something was there.
Okay. So let me ask this way, right? The resistor is connected with wire leads, right? You see there is a wire, right? So at high frequencies, what will wire do? Wire is nothing but wire will have its self resistance, as well as wire will have some inductance. So what happens is that at higher frequencies, the resistor's behavior changes, and it's just not sole resistor itself. I will explain you in detail what and how and what exactly happens to resistor. Before we move there, a film resistor is basically said SMD resistor. It's called surface mount device resistor. So you see 102, that is also a resistor. We never use those film resistors on microwave PCB boards. You see this PCB, you will never see any resistor here. All the resistors are SMD resistors like this. And you solder them.
Yes, sir.
है ना? तुमने देखा भी होगा इस चीज को. तो
Yes, sir. It is also on the Arduino board.
Exactly, and then you solder them on PCB board. So
Yes, sir.
why? Now we will try to dig more into it, and please start following from here. If you don't understand, ask me question, because I will leave this first lecture with bunch of questions, and you will guys have to figure out answers. I will tell concepts, but I will never tell answers. Up to you guys. Have to figure out answers. If you can't, your problem. Those questions can again come in exam. You can ask me, but I will never tell you final answers of questions. Okay, so this is what happens. A resistor at microwave frequencies is no more a resistor, but it has, like if you take a thin film resistor, it has two leads, right? Two wires. So wo wires are LLN inductors. So these wire, this wire and this wire, if you see, these are nothing but this is acting as an inductor and this is acting as an inductor. So this is an L and L. This part is R, which is the actual value of resistance. Okay. Now between this and this, because it is no more just a wire, it has inductance, there is interlead capacitance between these two. Okay. Similarly here, right, in SMD resistor, capacitance is what? Capacitance is whenever there are two, metals, unke beech, there will be always some capacitance. So then there is this interlead capacitance. Okay. And the third thing is stray capacitance, which is Ca here, which means this is the capacitance which is coming from the inside the resistor itself, because you use different thin films, you use different metals. The capacitance which comes across those metals is the stray capacitance. So at microwave frequency, what happens? Resistor no more behaves like an ideal resistor. So for example, if I say, hey, I want a 50 ohm resistance. Okay. So 50 ohm resistance, that value is at DC, which means that value will be at 1 hertz, 1 kilohertz, very, very low frequency. Maybe up to 1 megahertz that might be true. Maybe up to 10 megahertz might be true. Maybe up to 100 megahertz that might be true. So that R is only valid to certain frequencies. But as you start scaling up frequencies, resistor never remains like a resistor. So that's why it's so challenging to design at millimeter wave and at high frequencies, because every circuit component is not behaving the way it is supposed to behave. So now a resistor will have inductance. It will have what? Lead inductance, interlead capacitance, and stray capacitance. So before we move ahead, let's go slowly, step by step, trying to understand how can we calculate these lead inductances. Okay. So first of all, how you define a resistance of a conductor. So for example, you have a cylinder and you have a conductor. It has a radius A, length L, and it has some conductivity, because if you have a copper wire, right, that copper cylinder will have some conductivity through which will allow the flow of electrons. So the DC resistance value, and remember why I'm putting DC here, because this is only valid at DC, is a function of length over the area, which is here in this case pi r square or pi a square times conductivity, which means resistance is inversely proportional to conductivity. More the conductivity of something, less will be the resistance. Less conductivity, more will be the resistance. But it is inversely proportional to A, which is your radius of that particular cylinder. So this is how you define a resistance at DC of something like, of this resistor or this resistor. But the problem is at microwave frequencies, as we talked earlier, it's not just about this DC resistance. There is about what is the value of these inductance. So the lead, what happens is that as a function of frequency, what happens in a cylinder? You will have electric field, you will have magnetic field. And now because of the behavior of electric field and magnetic field, you will have some permeability, conductivity, and what you will see that the resistance, will decrease as a function of frequency. You will see that permeability, conductivity, there is a decrease in resistance and reactance, and that is called skin depth. What is this skin depth? Skin depth is a measure of how far electric conduction takes place in a conductor, and it is a function of frequency. Matlab kitna andar tak of that a particular conductor electrical conduction can happen. That is what skin depth is. And skin depth actually also means, at a point where resistance start decreasing up to 1 1 by E. Well, that's like more theoretical definition, but you guys should read this document. I have attached it here. There's a beautiful story about skin depth. Like this is a story between two people. I won't go through it, but I just put it because I found it interesting. So what skin depth is, that skin depth is a measure of how far electric conduction takes place in conductor and is a function of frequency. So at DC, right, at 0 hertz, the entire conductor is used, and whatever thickness is, everything will be used. In entire conductor, current will be flowing. Okay, but what happens is that at high frequencies, the effect of thickness of the conductor is basically the impact, like it says, at RF frequencies, the effect that conductor thickness has on its conductance or resistance is non-linear. तो मतलब कि point ये है कि the conductivity depends on the thickness. At DC, your conductivity is constant all across the conductor, but at RF frequencies, the resistance will vary as the length of the conductor varies. And because of that, there is a limitation on conductance, or there is a limit on resistance what you can achieve. And that particular thing is called skin depth, कि कितना उसका अंदर deep conductivity allow रहेगी. And that's what is mentioned here. And it's a function of frequency, permeability, conductivity, and pi is a constant here. So you understand pi, you understand frequency, you understand conductivity, permeability, again, how much that particular conductor allow the flow of electric fields. That is what mu is here. Now the lead inductance is basically is given as a function of frequency, because skin depth is a function of frequency. So inductance is also a function of frequency, is given by RDC into A. A is here the radius over 2 omega and skin depth. Omega is 2 pi f. So this is how you will calculate inductance, lead inductance of a given resistor. So it is a function of what? RDC, radius, omega. Omega is a function of f. Omega is equal to 2 pi f, and skin depth. So you can substitute it and you will know what will be the lead inductance. Okay. Now the point is, oops, sorry. Why I can't see this? There is some issue here. Okay, now I can see it. Did you guys understand it, or is it like going above the head? Please ask if you are not understanding something. Any questions?
So this is the internal architecture of a film resistor, no?
Yeah, this is
Yes,
a
SMD resistor.
equivalent model at high frequency. How a resistor look like?
Okay.
I'm
In
sorry,
both the resistors.
please say your. I'm not seeing the list right now.
Hello, can you hear me?
Yeah, I can hear you. What's your name?
Yeah. So my name is Manali.
Okay, Manali. Yeah, this is equivalent equivalent model of resistance. Yeah.
Okay, this architecture of both resistors. That's my question.
Yes, is the same.
Yeah.
Architecture of is the same. But
Internal architecture, sir. Actually, are you saying?
देखो इसमें क्या difference है ना? Film resistor will have lead inductance because you have these big wires. Why you use SMD resistors? You want to kill these. You don't want these, because if this will be there, if there is any inductance is a function of frequency. Capacitance is a function of frequency. So technically your resistor value should always be constant over frequency, but because of parasitics of C and L, your resistor value will change with frequency, which you don't want. So from moving from film resistor to SMD, you minimize these parasitic interlead capacitances and inductances. Okay.
So what is parasitics? I didn't get.
So parasitics basically are anything like lead inductance, tray capacitance, interlead capacitance. These are all called parasitics.
Okay,
It's just any extra thing apart from your actual thing which creates, I will say, problem, or which is undesirable, is called parasitic. It comes from parasite, right? Parasite kya karta hai? It's like a dimak, right? It kills stuff, useful stuff. Similarly, these parasitic if effects kill your resistant values. Okay, so now this is important to understand, right? When we buy a resistor from market, so basically what happens is that um, there is something called as AWG, American Wire Gauge. This is nothing but a standard, so don't apply too much brain here, what and why. It just says that the diameter of wire doubles every 6 gauge starting 1 mil for AWG 50 wire, which means क्या होता है कि जब हम वायर खरीदने जाते हैं ना मार्केट में, तो you define it like this: AWG 30, AWG 20, AWG 50 wire दे दो. तो every wire number AWG 50 has a specific length associated with it. Okay, and I think someone is not on mute. Can please everyone mute themselves? Yeah, thank you. So what happens is that the diameter of that wire, which we go and buy in the market, doubles every 6 days. Chaman or Dhirendra, I don't know who is doing brush right now, but please mute yourself. Okay. You guys can hear me?
yes, sir.
Okay. So let me go back to this again. So what AWG system says that the diameter of a wire doubles every 6 gauge starting 1 mil for AWG 50 wire, which means AWG 50 AWG 50 कोई तुमको बोलता है तो उस वायर का डायमीटर है 1 mil. Now if somebody says AWG 44, उस वायर का डायमीटर क्या हो जाएगा 2 mil. If somebody says AWG 38, उस वायर का डायमीटर क्या हो जाएगा 4 mils. So every AWG 50 is the starting point, and then numbers go down. This is just a system. It's like a stupid American standard system which everyone follows. But this is something to just remember, that when you go and buy a wire, they will just not simply tell it's a diameter 1 mil diameter wire. They will say, oh, give me AWG 50 wire. So you will know that AWG 50 wire has a diameter of 1 mil. Okay, so I will give you an example here. Okay, so for example, what will be the radius of AWG 26 diameter wire if AWG 50 is 1 mil? So this is a question, so let's try to solve it. Let me know if who finds the answer first.
So 4 millimeter.
4.
No, wrong. Again, go back to the
16.
Did everyone understand? Can you explain why it is 16?
Sir, it doubles every time. So the first time it's 1 millimeter, then it's 2, then it's 4, then it's 8, then it's 16 millimeter.
सबको समझ आया what he said? So basically what he's saying, at 50, the answer is actually 8. Okay? At 50, the diameter is 1 mil. Then at 44, it will be 2 mil. At 38, it will be 4 mil. At 32, it will be 8 mil. And at 26, it will be 16 mil. So diameter will be 16 mil. So the radius will be 8 mil. Because it doubles, as it said, it doubles every 6 gauge. which means 50 से जब 44 पे आए तो it doubled from 1 mil to 2 mil. 44 से 38 आए तो it doubled from 2 mil to 4 mil. 38 से 32 आए तो it doubled from 4 to 8, and then 32 से 36 it doubled from 8 to 16. So that answer is correct. Your radius of AWG 26 diameter wire will be 16 mil, and this is standard. It's not something like rocket science. You can Google it and you will find it. But now let's come up with a question, and I want you guys to solve this question right now. How much time we have, by the way, left? Half an hour?
Yes, sir.
Okay. So question is, calculate the high frequency impedance, okay, which means now I have a 500 ohms resistor with 2.5 centimeter copper wire of AWG26 and a stray capacitance of 5 puff. Assume there is no interlead capacitance. So what will be the high frequency impedance of that resistor? What I want to know is what will be your approach. I don't want answer because you won't be able to figure out answer of this question. I guarantee you. If somebody wants, if I will show you the answer in the next slide. If somebody can replicate it and bring it to me, solving himself, I give you full marks for assignment 1. So this is what we know so far, and we know about. So it is saying that there is a stray capacitance, interlead capacitance is 0. It is saying that there is a resistance of value 500 ohms, so which means this R is 500, and the stray capacitance is 5 puff, so CA is 5, and it is asking us what will be the high frequency impedance of this resistor. So tell me, how will you approach this problem? So first of all, what do you want to know in this? You want to know, you take this equivalent circuit and CB is 0. So if CB is 0, can you find what will be the equivalent impedance of this circuit?
So the impedance of equivalent impedance can be found by using that the impedance of a conductor or capacitor are at a phase of 90 degree with that of resistance, and we can calculate lead resistance by first calculating the radius.
By first calculating the radius. You know the radius? No.
Yeah, so like just we did in previous question, and we know the frequency.
Okay. I think you are getting it, but what will, before that, right? Can you calculate equivalent impedance of this circuit? So basically R and C are in parallel. So 1 over R plus 1 over XC is equal to the equivalent of this RC, right? So the equivalent of this will be 1 over R plus j omega C, right? Plus it is in series with 2L, so it will be plus j omega 2L, right? So that will be the equivalent impedance which you have to calculate.
Yes, sir.
And now in that, what you need lead inductance, right? And how will you calculate lead inductance? Lead inductance is a function of skin depth, omega, and RDC. So you will need to calculate RDC. For RDC, you need A. A is the radius, and radius is AWG 626 wire, which we calculated is 8 mils. So you know A. I have given the values of mu, sigma, and what is mil to, sorry, this should be meters. So this is mil to meters. I have given you that value. Using all this, you can calculate what will be the total impedance of this network. I think if people haven't understand, please say I haven't understand, then I will actually try to explain it again. I have actually ordered that board which you guys told me, so maybe by next week I will be able to write also, so you guys will understand better. So let me open whiteboard. Oh, Can you see this whiteboard?
Yes, sir.
Yes, sir.
Okay. So let me see if I'm able to navigate myself through. I'm using it for the first time. I'm so sorry. I have ordered the thing. It will come in some time. So basically वो क्या कह रहा है ना? This is inductor, and then it has a capacitor, and then there is a resistor, and then there is an inductor. So if you have to calculate what will be the equivalent impedance of this network, ये L है, ये L है, and then this is CA, and this is your R, right? So these two are in parallel, right? तो अगर parallel में है तो 1 over इनका R equivalent कितना होगा? Is equal to 1 over R plus 1 over XC, right? So this is equal to 1 over R plus XC is 1 over j omega C. So this is j omega C, correct? और फिर what you can do is, ये zoom out कैसे होगा? Then what you can do, so you know what is your R total equivalent of this. Like of this, you know what is your R equivalent, which will be 1 over R plus j omega C. ठीक है? That is R of this. Now this is in series with inductance, right? So total Z will be what? 1 over R plus j omega C plus how much is the reactance of, do you guys know what is the reactance of an inductor? Is j omega L. ये पता है सबको या नहीं पता है? If it
Yes,
you guys
sir.
have, okay.
Yes, sir.
Okay. So this is your total impedance. ठीक है? तो अब this total impedance is a function of what? It's a function of L. Okay, omega, you know, omega is what? 2 pi f. And then it's a function of C. This C is CA. So CA value is given. So you know this. And also R. This R is unknown, right? This R we will have to calculate. Or sorry, this R is actually given in the problem. Let's go back to the question. It's actually given, it's 500 ohms. So what you have to do pretty much is this, you have to calculate L, and that L is given by this RDCA over 2 omega times skin depth, and skin depth is given here, F mu sigma. Mu is known, sigma is known. I have already given it here. So you know mu and you know sigma. तो इसको सबको substitute करोगे, then you should be able to find what is the value of L, and eventually you will get the value of Z. So my question is first this: can someone tell me, will L be a numeric value or it will be function of something? Because I haven't said anything about frequency. What I want is I haven't said that at what frequency, you know. So the value of inductance will be a function of frequency. Okay. And now when you will try to calculate Z, this Z will be function of, again, frequency and function of L. जहां तक मेरे को ध्यान है, L will be somewhere some constant over under root F. तो मैंने क्या किया था आज today? Do you guys know MATLAB?
Yes,
Yes, sir.
Little bit. So what I did was I took this problem, I solved it in MATLAB, and I'm plotting this. Why it is important, I will explain you. X-axis shows frequencies, Y-axis shows absolute value of impedance Z, which we will calculate by that calculation. Can someone explain me what this figure represent? I'm just plotting resistor here.
Return loss.
No, it's not return loss. It's absolute value of impedance. So you see, value of impedance क्या थी? 500 ohms, correct?
Yes, sir.
But this 500 ohms is at what frequency? DC, or at low frequency? So when you will plot, this is actually around 500 ohms idhar.
Yes, sir.
This is logarithmic scale. So this is 500. So what it is showing is up to certain frequency, it remains close to 500. But as your frequency increases 10 to the power 9, which is 1 gigahertz, the value of resistor starts changing. And when you are actually around 10 gigahertz and eventually you are at 100 gigahertz, your resistor is no more resistor. It has become a capacitor. Your capacitor effects start playing in. And then after certain frequency, it's changed. Inductive behavior starts dominating and it starts behaving more inductive. So your resistor technically remains resistor only up to this frequency, 10 to the power 8. Uske baad the behavior starts changing dramatically. Are you guys getting it?
Yes, sir.
So
Yes,
best
sir.
case scenario will be if you people can solve this problem using MATLAB and plot this, that will be best thing, because I did it myself today, like during day. I these are fresh slides. I made it like on the today itself, and I solved myself. And I have MATLAB codes. If you are not able to do it, I will share it with you. But I want everyone to understand what's happening. So it's a very simple thing. You have, again, summarizing, resistor is no more a resistor at higher frequencies. It becomes function of frequency. There is lead inductance, there is stray capacitance, there is interlead capacitance. In this particular problem, interlead capacitance is 0. So you can calculate what will be the Z equivalent of the circuit. You know the Z equivalent of the circuit as I draw it on the whiteboard. And from this, you know what you want. You want L, you have CA, you have R, and L can be calculated based on skin depth, RDC, and radius. Very simple. And then when you will do, there won't be a closed form solution of this. When you plot, you will understand that why plotting is important, because I want you to understand that resistor is no more a resistor. It is a combination. It has a capacitive behavior as well as it has a inductive behavior. Okay, any questions? If you guys are not understanding, tell me right away, क्योंकि अगर नहीं है तो I will write it down and share it within the class notes so that you can understand it. But what I'm trying to explain here should be straightforward. There is no harm in saying that I don't know. I mean, I can repeat it if you guys want. Because if this type of question might end up in the exam, so then that's why I'm not giving solution right now. Today, I will leave you with open-ended these problems, and I want you guys to think and apply your brains. और next class में मैं randomly किसी को भी पूछूंगा कि इसका solution क्या कैसे. And I'm not interested in final answer. I am just interested in steps. Okay, moving next. Let's move to capacitor. You guys might have studied capacitor in your high school. A capacitor is nothing but a parallel plate. Parallel plate, it's like between two metal plates, you have some dielectric. So capacitor of a parallel plate capacitance is given by epsilon naught, epsilon r, which is together like an epsilon, permittivity, times area over d. D is the spacing between those two metal plates. That is your capacitance for a parallel plate capacitor. But this assumes that capacitors dielectric. What is a dielectric? Dielectric doesn't allow flow of current through it. Magar at microwave frequency, what happens is the dielectric is no more an ideal dielectric. There is a current which starts flowing through these dielectric. And because of that, dielectric become lossy. ठीक है? तो जब dielectric become lossy, तो what happens is that it has a loss associated with this. So this Re is called dielectric loss resistance. So the capacitance doesn't have only capacitance, but it has a dielectric loss resistance, which is given by Re. ठीक है? So capacitance के parallel में अब R आ गया. Of course, there is a lead. So if there is a lead, there always be a lead inductance along with a series resistance. So This is an equivalent circuit of a capacitor at microwave frequencies or at high frequencies. Here, Rs is just given by RDC times A over 2 into skin depth. Plus L, you know how to calculate L from last, it will be calculated in the same way as it was calculated in slide 13. अब इसमें इंटरेस्टिंग ये हो जाता है, this RE or GE, conductance, is actually function of conductivity of your dielectric, that how much dielectric allows flow of current, A over D, area over diameter, and then you can actually substitute this sigma dielectric as a function of permittivity omega E over tan delta S. This tan delta S is called series loss tangent. I will explain you. This might sound little weird to you guys, like why it is coming right away. Why I am not going into the derivation of all this, because I don't want you guys to go and understand, or you can read if you want from textbook, but my focus is to focus on application of this, that why series loss tangent is important. तो क्या होता है कि this dielectric loss जो होता है ना, dielectric, you guys understood, in the dielectric is no more 100% conductor. Sorry, it's not. Technically it should not allow any current, but because of the losses involved, and the dielectric is of specific material, right? Like Al2O3, for example. So it will have some dielectric constant, but with that it will also have a loss tangent, which means that how the dielectric will become lossy as a function of distance. So that particular thing, basically what happens is that particular thing is called loss tangent, and this is this GE here or RE is just reciprocal of this, is a function of loss tangent and is the function of capacitance. मतलब जितना बड़ा कैप होगा ना, because capacitance क्या है, एप्सिलॉन A by D, जितना बड़ा एरिया होगा कैपेसिटर का उतना ही बड़ा तुम्हारा ये डाइलेक्ट्रिक लॉस रेजिस्टेंस होगा. Smaller the cap, smaller the area, less will be the dielectric loss resistance. So many times when you go and buy capacitance in the market, now they have this something called as equivalent series resistance, which is RE, which is given here, or ESR. So basically ESR is nothing but just I think it should be 1 over this. This is wrong. 1 over GE. तो इसका reciprocal होता है बस, like GE का. So let me give you a practical example. Go here. So when we buy capacitor in the market, right? क्या होता है कि कोई कहेगा मैं प्रोजेक्ट बना रहा हूँ, मुझको 10 picofarad का कैपेसिटर चाहिए, and it is at certain frequency. Okay, so let's say we want 10 puff capacitor, so we will put 10, and say you want it at 10 megahertz. So you see, you got a capacitance of 10 puff, it's available, but then they show something like a series resonance, and then it will have voltage rating, and then you see ESR. This is what I was talking about, series resistance, and it says it's less than 0.79 ohms. Don't worry about this stuff, but what I'm trying to say is how you will know what type of capacitor you have to select. तो उसके लिए it is very important कि you go to specific, whatever capacitance you want, and you try to first see whether this type of capacitor is even available or not, है ना? तो you will enter whatever the capacitance value is. Again, let's do 20 puff, and say I want 20 puff capacitor at 10 gigahertz. So when you will calculate, now you will exactly know it is showing that there is a capacitance of 20 puff, but it shows that your series resonance is actually 2 gigahertz for that. So technically you want a capacitance, if you are planning to buy a capacitor, its series resonance should be higher than the value of that cap. So this capacitor cannot be used, it means. and then it will have a maximum current rating, and it will have ESR. This ESR, why it is important? Because it is the loss associated with capacitor. तो इस कैपेसिटर के साइड पर ये इसका एक्टिव एरिया है, बट व्हाट this gray color brings inductance to it and as well as the series resistance to it. So this is how we try to see and try to find what type of capacitor we want to use. So if there will be the one, then I can select whichever it is, and then I can place an order of it. So this is just important because resonance frequency अगर किसी की कम है ना, what is a resonance frequency? Resonance frequency is a point after which a capacitor will start behaving like an inductor. तो अगर तुम 20 पफ का कैपेसिटर 10 गीगाहर्ट्ज पे यूज कर रहे हो ना, इट मींस इट इज नो मोर अ कैपेसिटर, इट हैज ऑलरेडी बिकेम एन इंडक्टर. तो these things are important to understand. Otherwise क्या होता है कि people even don't know what they think capacitor is just capacitor. But yeah, if I want 0.5 picofarad capacitor, I can use it. The resonance frequency is 15 gigahertz. So no problem. I can use it at 10 gigahertz. So there is a specific value of a capacitor which can use up to a frequency, because otherwise you won't be able to use it. So anyways, this calculator I just put it. If you guys want to play with it, you can. Otherwise, all formulas are given here. So there is a capacitor. Remember dielectric loss resistance, series resistance, lead inductance. You know how to calculate from slide 13th, and then you know how to calculate RS, and then you will know how to calculate RE. With all this, you will be able to estimate the value of DL capacitor.
Sir, but this series resistance, have we applied this externally? या फिर this is equivalent representation of a capacitor at high frequency?
This is not applied externally. This is the resistance which exists from internally at high frequency, मतलब caps. जैसे यहाँ पर देख रहे हो ये gray. So because the way we are adding pads, we will solder here to this PCB. So this part adds series resistance to my cap. And then this inductance is also coming from the same thing. मतलब इस पोर्शन का RB होगा, LB होगा, और ये बीच का कैप होगा. क्योंकि ये जो part है ना, you can't ignore it at low frequency. At low frequency this gets ignored, but at high frequency this also has effect.
Okay. So sir, ये जो capacitance वाला part है, I mean wherein at high frequency we introduce RE, ये तब आता है ना, ये sorry, ये white वाला part है ना जो आपने उस diagram में बताया. This happens because of the white part, but the rest happens because of the padding that we add at the.
Exactly. ये C और RE जो है ना, ये white के अंदर है.
Okay sir.
Exactly. You got it. Did you guys know that this thing might happen at high frequencies? Were you guys aware of this?
Sir, we were aware, but we weren't mathematically sound.
Okay. So yeah. So why it is good to study mathematically? Because now you at least understand ना, मतलब lead inductance है तो lead inductance किसका function होगा, series resistance है तो skin depth का function होगा, उसका radius का function होगा, and so on. So let me go next. Because how much time we left? Please tell me when I have to end.
So 20 minutes.
20 minutes. Okay. I think let's finish this because otherwise we will miss it out. So here's a capacitor equivalent problem. Compute high frequency impedance of a capacitor of 47 puff whose dielectric has a loss tangent of 10 to the power minus 4 and leads are AWG 26 copper wire with length 1.25 centimeter. Read it, try to digest it first, and then we can discuss. ओके, सो कैसे करेंगे इसको सॉल्व? So first of all, what will be the equivalent Z of this network? Let's go back to whiteboard. So what it is saying that it has L, R, C and R, right? So it has L, R and then C and R. तो ये दोनों तो पैरेलल में हो गए एंड ये दोनों सीरीज में हो गए. So this is L, this is RS, this is RE and this is capacitance, right? Then so what will you do? How can you write Z? So 1 over, first of all, same, इसका तो हो गया j omega L plus RS, right? And this is in series with this and this is in parallel. So if it is in parallel, it will be 1 over RE plus 1 over j omega 1 over XC. So ये हो गया j omega C is equal to इन दोनों का equivalent resistance, right? So I can write this R dash as RE over 1 plus j omega C RE और इसको सब्स्टिट्यूट कर दो वापस इधर. So this becomes j omega L plus RS plus RE over 1 plus j omega C RE. ठीक है. अब इसमें you know omega is 2 pi f, है ना? अब RS हमको पता है, it's given, right? It says that what is RS we know is RDC over A over 2 lambda. So we know it has given value of 47 puff is the value of capacitor. Dielectric loss strength, copper wire का length दिया हुआ है, AW6 copper wire है, तो we know what is the radius of wire, right? Since we know the radius of wire, so we know basically what is the RS. We know capacitance, this capacitance is 47. We know omega. Mainly we have to calculate RE here and L. L you can calculate as we calculated earlier, and for RE it's very simple. RE is given by this. RE is equal to what? 10 delta S over omega C, right? Because GE ka 1 over GE will be RE. So capacitance 10 delta, you know, tangent, omega is 2 pi f. C is the capacitance and capacitance value is known. With substituting that, you will be able to calculate the equivalent impedance. फिर again, when you calculate impedance and you plot, you will see that ideally capacitance क्या होता है? Ideally अगर तुमको एक capacitor का reactance plot करना है, that is what? 1 over 2 pi fc, right? So as a function of frequency, the value or the reactance of a capacitor changes, and it is usually like this, you know, in a logarithmic scale. Ideal capacitor is like this, but in reality what happens due to the inductance, due to this L which we talked about, you know, and the dielectric loss resistance, क्या होता है? The capacitors become changes and starts behaving like an inductor. So that is why it's very important to understand the concept of resonance frequency of capacitor. Agar resonance frequency of capacitor is lower than your desired frequency of operation, it means, what it means, कि you won't be able to use that cap. So agar kal ko somebody comes, you know, and says, hey, I have a capacitor and the value of capacitor is 5 picofarad and I am designing a circuit for 5G. Okay, you are designing circuit for 5G at 28 gigahertz and you are designing circuit for 5G at 6 gigahertz, you might not be able to use same value of capacitor. So that's why it becomes very challenging to design, and you need a lot of skill because things get very limited. And these capacitors have to be actually EM simulated, electromagnetic में plates बनाकर CAD में drawing करके, then we have to excite them in CAD tools and see what their response is. Did you guys get it? How to go from what will be the approach to solve this problem, or no?
Yes, sir.
किसने बोला yes?
Sir, me.
Kunal, okay. What about Manas? Manas, are you understanding anything or सब ऊपर से जा रहा है?
Then it's understood, sir.
पक्का?
Yes, sir.
तो समझाओ फिर क्या why the capacitor in this particular example, what is happening here? What is happening with the real capacitor?
The real capacitor turns into an inductor as the frequency increases.
Good. That's because of the effects which we studied here, because of the lead inductance and the other parasitic effects.
Yes, sir.
ठीक है? Very good. So I think now, since we have another 10-15 minutes left, I will just try to go to an inductor and then we can close it. Now inductor is very interesting because क्या होता है, inductor is an element which is used a lot, right? और inductor को हम, can someone tell me where inductor is used maximum, like कहाँ पर inductor का सबसे ज्यादा यूज होता है? कोई बताएगा? आप लोगों ने कभी इंडक्टर देखा है?
Sir, generators.
Yes. So any coil is an inductor, first of all, है ना? Anything which will have a winding will be an inductor. और inductors की खासियत ये होती है कि you can take any wire, and you can make coil out of it, but if it is excited, a magnetic flux passing through that particular coil will change over time, and that particular wire will start behaving like an inductor. तो अब इस particular case में देखो, you have this coil. तो at high frequency, what is happening? The coil itself, there is an inductance for sure, but उसके अलावा between two coils, which you see here, there is a capacitance. क्यों? वो दो coil को you can consider them as parallel plate. You can consider them as parallel conductors. तो उन दोनों के बीच में क्या होगा? Capacitive effect होगा. फिर along with that, because nothing is an ideal conductor, there will be a series resistance. ठीक है? और जो series resistance होता है ना, we can basically, it's very simple. It's just the हमने यहाँ पर पढ़ा था, this RDC. This will always exist in a conductor. ठीक है? तो there will be some RD, and apart from that, there will be different number of turns and total length. So if I want to draw an equivalent ना, there is a wire. Wire का क्या है? Diameter है. Diameter क्या है? 2a. Then there is a spacing between two coils, जो भी हैं वो d है. Then there is a total radius, total diameter, कि कितना coil, कितना बड़ा है total coil, and then there is the length L. ठीक है? So the inductance is given by area, which is here, in this case R is your radius pi r square, times your mu naught is your permeability, times your number of turns, n square over L here, sorry, this should be small l, not capital L, because otherwise confusion होगी. So this inductance is given as a function of number of turns, your radius of the coil, and your length, कितनी उसकी length है. ठीक है? That will give you this L. Now the question is, what is RS? RS is same as RDC, which is length, कितनी मेरी length है ये total, over my area, which is pi a square in this case, क्योंकि इसकी ये जो wire है, इसकी जो length है वो sorry, इसका जो area होगा वो pi a square होगा, into sigma is my whatever your conductivity, and the total length is nothing but what? 2 pi r, because ये total diameter 2r है, so radius is r. 2 pi r times एक coil का कितना होगा? 2 pi r होगा circumference. So your multiply by number of turns will give you total length. So similarly, now capacitance kitna hoga? Epsilon A by D. A is what is your area? Area is what? 2A is the diameter of this times jitni length hai. वो total area हो गया और length कितनी हो गई? Circumference of it 2 pi r into n है ना. और d distance is nothing but L divided by number of turns. उसको substitute करेंगे तो CS हमको मिल जाएगा. CS is 4 pi epsilon RA n square over L. So basically, I mean, you can just go over it. It's nothing that crazy. Just substitution, and you will be able to get L, RS, and CS. Now, again, the question is, how will you compute the equivalent impedance of this? So that's like simple again. So what is this? This is an inductor. So going back, inductor का equivalent हमारा L था, R था और C था, है ना. तो this is L, this is R, this is C, है ना. So these two are in series. So I can write j omega L plus R, and this C is 1 over j omega C इनका XC. So these now again these two are in parallel. So it will be 1 over R plus j omega L plus 1 over C, so that will be j omega C, and that's 1 over Z equivalent. ठीक है, तो इसको मल्टीप्लाई कर देंगे 1 plus j omega C times R plus j omega L over R plus j omega L. तो अब इसमें सिंपल है, you know what is your omega, you know again you can calculate C, you can calculate R, and you can calculate L. इसके लिए क्या चाहिए होगा? Number of turns, area A, length L, D, the spacing between them. This is all what you need. That's it. And mu, permeability. So उसके through you can calculate whatever you want. ठीक है, so with this you will be able to calculate the value. So there is a question here. Here is these values. I have given length of the coil, I have given the radius of the coil. AWG 36 wire hai, so you will also know what is the radius of the wire itself. So you know A, you know R, you know L, you know D, which is L upon N, you know number of turns. So you will have to calculate the equivalent impedance. ठीक है? Did you guys get it?
Yes, sir.
Yes, sir.
So these all questions now, slide 19th or slide 16th and slide 13th, these all are assignments. I mean, you guys have to do it. मेरा assignment का क्या होगा ना, I will leave this question and in a week's time I will ask you to submit it, or maybe give you more, like end of 1 week. So how does usually assignment work? It's like they do it with every lecture, or they do it after few lectures?
Sir, after a few lectures.
But मैं नहीं follow करूँगा वो. My style of assignments will be right. आज का जो lecture हुआ उसके ये 3 problem statements हैं. You guys have to solve it. You can take time up to next class. मतलब next week, like next Friday, I will ask you to submit the answers of these questions. Got it?
Okay, sir.
Okay, sir.
Because anyways these are easy in the sense I have already discussed answers, but I want you to practice, because अगर नहीं करोगे ना भूल जाओगे. तो अभी क्या होगा, अब मैं ट्रांसमिशन लाइंस पर जाऊंगा ना, तो things will start getting complicated. So I want you guys to speed up yourself. नहीं तो you will be lazy and you won't learn anything. So any questions?
So what about next topic?
Next topic means?
In next class.
Next class we will be reading transmission lines.
Okay, sir.
So basically I will start with what is a transmission line theory, what is the equivalent circuit of a transmission line, how to calculate characteristic impedance of the transmission line, when we are laying out a transmission line in a circuit, how we determine what should be the width, what should be the length of the transmission line, and what are the different types of transmission line and all that stuff. So I guess that might need next whole week we will be studying transmission lines. And if I have, what I will try to do next week, once we finish these passives and we finish transmission lines, I will try to run some simulation and show you on software. You guys might not have it, but I will try to show them at my end. You know what I mean? I have software with me. I can at least show you that until we finally get all figured out with the licenses and stuff. Okay. So I will upload this lecture today on the drive, like the Google Drive. Do you guys have access to the Google Drive?
Sir, sir, have you created a Google Classroom yet? Because if you have, we can get access to that. Otherwise.
Okay, I have created a Google Classroom and also a Drive. So I will upload lecture 1, and I will also upload I will ask you guys to submit the assignment 1. So I will also upload just a note there with the dates and the deadlines in this slide deck. So maybe by tomorrow morning, because it's late night here for me. So tomorrow morning I will try to upload it with a specific date. And for the assignment submission, वो तो सब लोग अलग-अलग सबमिट करते हो या सब एक साथ उसमें भी ग्रुप बना के करते हैं लोग?
So that usually depends on the assignment.
Okay, so this is easy. So I guess everyone should be able to do by themselves. Or what do you guys recommend? I guess for this, I will recommend all people submit their assignment themselves, and I will then give a deadline, and you guys can send me the just do. It's an open book. You can use whatever you want, and I just want to see the final results along with your MATLAB code. If you try to plot them, then I need MATLAB code. If you guys don't have MATLAB and you don't know MATLAB, you can also use Wolfram Alpha for plotting. If you even don't have that, don't plot it. Just give me the final equations which should be plotted. I can mark that also, so it's not a problem. Like just mention the steps.
Sir, everyone don't have MATLAB license, so that
Everyone don't have MATLAB license. Don't do.
Some people have.
Achha. So don't do plotting then. Leave plotting part and just leave the final equations, because plots are already there in the slides. Those are the answers, actually, final answers. But what I want you guys, from question to the final answers, I want you guys to go through the process, so that you read about skin depth, you read about all the formulas, what are there, and it is somewhat in your brains. And then if you want, one day, once you all submit, we can go through in the MATLAB. I can share the codes, and if you guys want to plot, you can plot them. It's straightforward, 5-line code.
Okay, sir.
And I don't know if you guys do Python or C++, but you guys can also plot it in other softwares. It's very straightforward, like nothing very difficult. Anyways, so next class I will be talking about transmission lines. Do attend that, because if you miss that, after transmission lines, what will happen, that we will start doing Smith chart matching. I hope I will get my that tablet by then, so that I can show you guys how to do that plotting. In meanwhile, you guys will need some Smith chart and some compass and pencil and scale and stuff. I will send you the requirements, so that in those classes you have, so that we can do plotting together, and then we will see. And if you have any comments and suggestion how I can improve my teaching moving ahead, please feel free to email me. That will help me a lot. Okay. So with that, I think it's good for today, and I will see you guys now on Wednesday, next Wednesday. Bye bye.
Thank you, sir.
Okay, bye.